Hello students, in this video we shall discuss the chapter 8, that is motion of class 9 science. Now see, in order to describe the motion I have drawn a distance between the 2 points. See, distance between O to A of 70 kilometer distance, and in between I have marked 2 points. So I have split the distance into some points. Just I have marked the 5 kilometer apart some points in between the distance. See, first 0, 0 to 5, 5 to 10, 10 to 15, 20, 15 to 20, 20 to 25. This way I have marked these points. Now, when an object starts from O, this way, so it will, when it will reach at C, it has traveled 25. See, first OC, distance of OC is 25 kilometer. These are all distance in kilometer. When the object reaches the point B, then it is OB. It is 45 kilometer. And when it reaches at A, then OA equal to 70 kilometer. So when an object starts from O to O, it reaches C, travel 25 kilometer, then B, and then A. So it has traveled a distance of total 70 kilometer. Now when it will come back, when this object again comes back from A, then when it comes back from A and reaches the point B, then what would be the distance? That distance will be O to A and distance O to B. Note it, first it has already reached A and then comes back to B. Then how much distance it has traveled? 0 to 70 already it has traveled, plus again how many kilometers are there, you see, from 70? 1 2 3 4 5 kilometer. So answer is 75 kilometer. When it reaches C, then distance is already 75 kilometers it is traveled now. 1 2 3 4, so 75 plus 4, that is 79 kilometer. And when it again reaches O, then total distance is 70 plus 70, definitely, that is 140 kilometer. This way we measured the distance. This is the distance traveled by an object in a motion. But there are two terms are there, distance and displacement. Definitely a body, an object undergoes displacement during motion. Otherwise it won't be a motion. The body is not said to be in motion if it not displaces its position. Now what is the displacement? Displacement means nothing but the difference between the initial position of the object and the final position. Initial position and the final position. So first see, the object starts from the point O. So initial point of the object is O. Then it reaches C, and then that will be the final position. So displacement is 25 kilometer, sure. But when it reaches B, so displacement is, suppose if starts from O and stops at B, then displacement is 45 kilometer. When it reaches A, displacement is 70 kilometer. But when an object, if the object starts from C and to B, then displacement will be only 4 kilometer. this way, just the difference between final initial position and final position. So distance between the initial position and final position. So when the object starts from O and it reaches E, total displacement is 70 km, and when it comes back and reaches again at B, then displacement will be OB, nothing but the OB, total distance traveled. So distance between the initial and final position this, and final position this. So total distance is actually, what is the distance between O and B? It is 45 km. So that time displacement will be just displacement OC is 25 km, OB 45, OA is 70 km. But in that case, it is when it reaches B, it is 45 km only, and when the object reaches C, then only 25 km, because that in that case the final position is C and initial position was O. So what is the distance between O and C? Just the distance between the initial position and the final position. So this is the distance between the initial and final position, only 25 km. This is the displacement. But if I count the distance, what distance it has traveled, then already we have calculated here, see 79 km, this way. When object again comes back to O, then displacement will be 0, because this is the initial position and again this is the final position. So both the points coincides. So in this case, displacement will be 0, because there is no distance between the points, but it has traveled the distance of 140 km. If I calculate the distance, that is 140 km, but if we calculate the displacement, it is 0, this way. Next, uniform motion and non-uniform motion. What is the uniform and non-uniform motion? See, when the object covers equal distances in equal interval of time, it is said to be in uniform motion. Suppose I have given the interval 0 to 5, these are all in minutes. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20. These are the time intervals. So in 0 to 5, it has traveled, say, 5 km. And in next 5 to 10, again it has traveled 5 km. Equal distance it is covering, the object is covering equal distances in equal interval of times. This type of motion is said to be uniform motion. And if an object covers unequal distances in equal or unequal interval of time, I mean any of the factors or any two both the factors is unequal in case of the motion of an object, then those will be a non-uniform motion. So in our day-to-day life, we come across the motions where objects covers unequal distance in equal interval of times. Actually the time intervals remains equal most of the times, but it travels unequal distances. We also when we go out from the home, you can observe in equal interval of time we travel unequal distances. This type of motion are called non-uniform motion. All right. Next, speed. See, this expression already I got in your earlier classes. Speed equal to distance divided by time. This way we find the speed of an object. So what is the speed actually? It is nothing but the distance. When we measure the distance with respect to time, then it becomes a speed. When we measure the distance of an object, distance traveled by an object with respect to time, that is rate of motion, this is called the speed. And SI unit of speed is meter per second, or you can write ms to the power minus 1 in terms of exponents. So the SI unit of distance is meter and time is second, so meter per second or meter second inverse. This way we can write. So if we find the average speed, it is total distance traveled by total time. Unit will remain same. Yes, this is an SI unit of speed. Another unit is there, that is higher unit is kilometer per hour or kilometer hour inverse. This way you can write. So this way we find the average speed. Now speed with direction. When the speed has a specific direction, then it becomes a velocity. The quantity that specifies both these aspects, that is the magnitude of the speed and a direction, that is called the velocity. Just it will have a specific direction, then it will have a velocity. And the SI unit of velocity is also same as the speed. So velocity has a specific direction, and we can find the magnitude and direction in a in case of velocity. So actually there are two types of velocities are there: initial velocities and final velocities. When an object starts, the starting velocity is called the initial velocity, and when attains another velocity or stops at any point, that is called the final velocity. Or the change in case the velocity of an object is changing at uniform rate, then average velocity is given by the arithmetic mean of initial velocity and the final velocity. See, then average velocity is equal to initial velocity plus final velocity divided by, this is the arithmetic mean of initial and final, and these are usually expressed as u and v. Initial velocity as u and final velocity as v, u plus v by 2. This way we can find the average velocity of an object, and the unit will remain the same as previous. So SI unit is meter per second or meter second inverse or kilometer per hour. Next we can find the rate of change of velocity. So what is the rate of change of velocity? Rate means measuring with respect to time. So already we have discussed the uniform motion and non-uniform motion. In uniform motion, what happens? The distance remains the same with respect to time. So the velocity will not be changed. Velocity will remain constant in this case. And we are talking about the change in velocity. So in case of uniform motion, there is no change in velocity. Note it. In case of uniform motion, there is no change of velocity, because the velocity or speed, actually velocity of the object will remain same with respect to time. But in case of non-uniform motion, the velocity will be changed. So then we can calculate the rate of change of velocity. So that is called actually acceleration. So this is actually nothing but the change in velocity. When we measure the change in velocity with respect to time, then it becomes the acceleration of an object. It may be positive or negative also. Anyway, let's see. Acceleration is usually denoted by a, and change in velocity, that is final velocity minus initial velocity, v minus u, and divided by t. So this is the expression of acceleration. So change in velocity, what is the in case of increasing acceleration, if the velocity is increasing, that is if initial velocity is less than the final velocity, in this case it is acceleration, and when final velocity is less than the initial velocity, in that case it will be retardation or negative acceleration. So what is the unit of this? See, v minus u, this is also velocity, so already we have got meter per second. Again t is in the denominator, so again second. So if we simplify, it is meter per second square, meter by m by s, and again s, so s will be multiplied, s into s will be s square, or we can write ms to the power minus 2. In the kilometer unit we can write kilometer hour to the power minus 2. However, this unit is not used usually. Actually, this unit is used, meter per seconds or meter per second square. All right. Next, I am showing a numerical sum. So just from your book, I am showing a sum. You see in the page number 103, this number 2 sum. In this question, it is given a bus decreases its speed from 80 km to 60 km in 5 seconds. Find the acceleration of the bus. So first given, you see, first there are two velocities. First one first velocity we can take as initial velocity, and it is represented as u. It is 80 km per hour. Now we must convert this into SI units. This is not in the SI unit. So how to convert? See, 80 kilometer must be converted to meter. So multiply by 1000, and hour to the power minus 1. So hour we need to convert into second. So sorry, 60 into 60, because 1 minute equal to 60 second, 60 second, and 1 hour equal to 60 minutes. So 60 into 60 twice we need to multiply. Now just simplify. So result is 20 by 9 meter per second, or we can write meter second inverse. Then final velocity is given 60 km per hour. Again convert this. So answer is 50 by 3 meter second inverse. Now time is given, it is 5 seconds. So second is already in the SI unit, no need to convert. So all the units are in SI unit. Now we can find the acceleration. Therefore acceleration, or simply I can write A is equal to V minus U by T. So V is actually 50 by 3. Now we should simplify. Take the LCM.